Hi everyone, my name is Naqash and I'll be presenting my research titled Submillimeter Lateral Displacement Enables Friction Sensing and Awareness of Surface Slipperiness. Without frictional information, we might not be able to perform various tasks with our hands, which involve gripping object surfaces. We adjust grip forces to be just enough so that sufficient frictional forces develop, maintaining safe contact with the object, and excessive forces are avoided which might damage delicate objects. For example, imagine holding a raspberry without squashing it, holding a cup of coffee, holding your body weight on a cliff face when rock climbing, walking with tools, or performing delicate surgeries. Human tactile perception and motor control rely on the frictional estimates that physically cannot be possible unless slip occurs. But the challenge is that when handling objects, we cannot afford slipping. The solution is partial slips in some parts of the contact instead of a full slip. It has been found in the previous studies that skin deformation patterns and radial divergence may account for such slips underlying friction estimate. However, in many situations, it is not sufficient. An additional tiny lateral strain may have a decisive effect enabling friction sensing when otherwise it wouldn't be possible. In the current study, we aim to investigate how small lateral displacement might be sufficient to enable friction sensing. We also evaluate the effect of speed of these movements. Here is the experimental setup where we used a friction reduction device to change the friction of a smooth surface. In a 2AFC task, stimuli were presented to the fixed index finger using a robotic manipulator, which after pressing the finger at 1 Newton moves the plate laterally at 4 different distances and at 3 different speeds. Here you can see from the figure that the displacement is so minute that it can hardly be observed. The graph on the right showing probability to correctly identify more slippery surface as the function of displacement distance indicate that for some subjects, lateral movement of 0.2 mm was sufficient to enable friction sensing, and performance improved with larger displacements. It has to be noted that without lateral movement, none of previously tested subjects could achieve above chance performance. One of the surprising findings in this study was that lateral movement speed had relatively small effect on discrimination of surface slipperiness, as shown in the figure on the left, even when displacement speed changes tenfold. Overall, we found that a small lateral movement of 0.2 to 0.5 mm of the touched surface relative to the rigid nail is sufficient to perceive surface slipperiness. Displacement speed changes even by tenfold had relatively little effect on friction perception. In motor control, natural movements when reaching and gripping objects would rarely occur without the presence of subtle lateral motion jitter. This study indicates that such natural movements are sufficient and potentially could be the key enabling us to feel slipperiness of the surface. Thank you.